This is a problem based on mathematical puzzle, and it is a bit difficult in nature. So while taking test, this sets should be attempted towards the end. Here we have three friends, Saptars, Rusat and Trivendra. Each has some red and white balls. Saptars has at least one red and twice as many white balls, which means if x is the number of red balls, then the number of white ball with him will be 2x. The total number of ball will be 3x, where x is greater than 1. Rusat has at least one red ball and three times as many white balls as red ball. If he has y red ball, then the number of white balls will be 3y, which means total number of balls will be 4y, where y is greater or equal to 1. In the next statement, it is given that Trivand has at least one red ball. If the number of red balls with Trivand is z, then the number of white ball will be 3 more than the red ball, g plus 3, which means 2z plus 3, where z is greater or equal to 1. So their balls could be like Satpus 3, 6, 9, 12, 15 and so on, and the number of balls with Rusat will be 4, 8, 12, 16 and so on, and the number of balls with Trivandra will be 5, 7, 9, 11, 13 and so on. In the last statement, it is given that when I tell you the number of balls we have together, the number is less than 24, which 25, which means the total number of balls at max can be 24. You'll know how many balls I have, but not how many balls each of the others has, said one of the friends. This is a very important statement. He's saying, if I tell you the total number of balls that we have put together, you will know how many balls I have, but not how many balls each of the others has, said one of the friends. It is only possible when we have situations like this, like we have 2-3 combos in which a total number of balls can be obtained, but there is a fixed number. Like if we take example of 22, then it can be obtained in the following manner: 9 plus 8 plus 5, 9 plus 4 plus 9, and 3 plus 12 plus 7. Here there are three ways in which 22 can be obtained. In two of the ways, one number is fixed, and in third way there is no common number with the first two ways, which means if the total number of ball is 22, then we would not be able to tell who is the person who is speaker here. But if it were the case like of 19, 6 plus 8 plus 5, 6 plus 4 plus 9, and there is no other ways in which 19 can be obtained by using one number from each of the three out of S, R and T. So in this arrangement, we can see that there is one number which is fixed in both the combination. So this number should be the number of ball with this speaker, and in that case we would not be able to tell what are the number of balls with the other two. So this is the meaning of last statement. Now let's see what could be the minimum number of balls with them. If we take the smaller number from each of the three sets out of S, R and T, then we get a sum of 12. This is 3 plus 4 plus 5, and there is no other ways in which 12 can be obtained, but this has to be the case that needs to be rejected, as in this case the number of balls with each of the three friends can be determined. Now coming to 13, there is no way we can find 13, as there are not such numbers that can give us a sum of 13. In case of 14, it is 7 plus, rather 3 plus 4 plus 7. Again there is only one way in which 14 can be obtained, so in this case we can determine ball with each of them, so this is not the required or acceptable case. Coming to 15, it can be written as 6 plus 4 plus 5, and there is only one way in which 15 can be written, so this needs to be ignored. Coming to the next number, that is 16. 16 can be obtained in two ways. First is 3 plus 4 plus 9, and second is 3 plus 8 plus 5, and there is no other ways in which 16 can be obtained. So from here we can see that there is one number in the two combination that is common, so this number should be the number of balls with this speaker, and the number of ball with each of the remaining others cannot be determined. So 16 could be, or a possible case of the total number of balls. Now coming to 17th, it can be obtained only one way. This is 6 plus 4 plus 7, and 18th can also be obtained in only one way. Now coming to 19th, just by observing here it is 3, if we double it then number obtained will be 19, or sum obtained will be 19. So 6 plus 4 plus 9 equals 6 plus 8 plus 5. There are only two ways in which 19 can be obtained. So 19 is also a case that satisfies the given conditions. Similarly we can check for 20, 21 and so on. 20, and in 21 there is only one way in which these two sums can be obtained. In case of 22 that we have already discussed, there are three ways, so this could not be a possibility. Similarly we can check for 23 and 24. We'll get only one combination for each of the two numbers, so the total number of balls with the three friends could be either 16 or 19. So let's move to the questions. In first question, it is asking the number of balls with the three friends put together cannot be more than, as we just discussed, the number of balls with the three friends could be either 16 or 19, so the number of balls could not be more than 19 in any case. Therefore option B is the correct answer. Coming to the next question, here it is asking who is this speaker. As in the case of 16 and 19, 3 and 6 were the fixed numbers, and these were the number of balls with the Satpurs. Therefore, the speaker is Satpurs, which is option A. In the next question, it is asking the number of balls with Satpurs cannot be more than, as we have already seen, the number of balls with Satpurs could be either 3 or 6, therefore it could not exceed 6. Hence, option C is the correct answer. In the last problem of this set, how it is asking how many balls does Rusat have. As we have already discussed, the number of balls with Rusat and Trivendra could not be determined, consequently cannot be determined will be the answer of this problem. So that's all about this set.